Make search respect title, body, and tags. By the end, you will have a tiny multi-field search you can explain and tweak. You will see how to score matches using TF-IDF style weights and IDF, and how shifting title and tag weights changes which documents win. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Multi-field search answers this real question. You have short titles, long article bodies, and a handful of tags. A plain single-field search treats every word the same and loses signal from concise fields like title or tags. Multi-field search makes those concise signals count more, so topical intent surfaces faster. The trade-off is you can overweight short fields and hurt recall when the body contains needed context, so balance matters. Think of each document as 3 buckets. One bucket holds the title, one holds the body, and one holds tags. Each bucket can vote on how well the document matches a query. TF-IDF is the classic way to score words, where IDF, inverse document frequency, downweights common words that appear everywhere. A concrete mini-example: a title match on a short, precise phrase should often beat a weak body match. That simple idea guides everything we build. We will build a small TF-IDF style ranker that creates multi-field documents and returns ranked results with adjustable title, body, and tag weights. This snippet builds tiny multi-field docs and counts query matches in one item. It creates a few short documents, each with a title, a body, and a list of tags. The code then tokenizes the fields and counts how many query words appear in each document. This gives a raw match count per document and per field. That raw count is useful to inspect initial signal, but it treats every word equally and every field equally. If you change how you tokenize, short tokens or stop words will alter these counts and change which documents look promising. Next, we will add a basic idea of rarity to the score. This snippet computes an IDF-weighted relevance score for the first document. It calculates inverse document frequency, which reduces the weight of common terms across the small corpus, and multiplies that by the term frequency inside fields. The example shows how a match in the body and a match in the title accumulate different amounts once you apply IDF. If you increase IDF sensitivity by treating rare terms as even more important, rare term matches will dominate rankings, and a noisy common term match will drop. This helps separate generic overlaps from truly informative matches. Now we expand the small corpus to see selection across documents. This snippet adds a third document and selects the best match using TF-IDF. It computes a simple TF-IDF score per field, sums field scores into a document score, and picks the highest scoring document for a query. The example shows how documents with many medium matches can lose to documents with fewer but rarer matches because of IDF. If you change the term frequency calculation to normalize by field length, longer bodies stop having an unfair advantage. That normalization choice affects precision and recall trade-offs on longer content. Next, we emphasize concise signals explicitly. This snippet boosts matches found in titles to emphasize concise intent signals. The code applies a boost factor to title matches before summing with body and tag scores. The result shows how a single precise title hit can outrank many body hits when the boost is high. If you increase the title boost, you favor concise coverage and reduce noise from long documents. If you lower the boost, you recover broader recall from bodies. Picking the boost is a tuning decision that depends on whether your queries seek short intent or wide context. Finally, we show a full weighted ranking across fields. This snippet ranks all documents using separate title, body, and tag weights. It computes per field TF-IDF, multiplies each field by its weight, and produces a final score list that you can sort. The example explains how to set the title weight high for search interfaces that want exact intent, or set tag weight high when tags are highly curated. Changing any weight shifts which documents rise to the top, and changes evaluation metrics like precision at 5 or NDCG. The code also shows a simple way to vary weights programmatically and inspect top results for each combination. Recap: multi-field search treats title, body, and tags as separate signals and combines them for ranking. Use it when fields carry different strengths, like short titles and long bodies. Caveat: overweighting a small field can hurt recall if the body contains essential content. Next step: tune the title, body, and tag weights while measuring a ranked metric like NDCG on a validation set to find the sweet spot for your use case. If Practical IR helps your projects, subscribe and watch the IR videos for more hands-on guides.